talking about complex numbers and the applications, we mentioned complex numbers, of course, they have this form. Z is equal to a real part A plus a imaginary part B, and we use J as our root -1, the imaginary number. We have this impedance of an inductor where Z is equal to J times omega L, where J is the imaginary number, L is the inductance measured in H of the inductor, that's Henry's, and omega is 2 pi times the frequency F of the alternating current measured in hertz. Find Z if L is equal to 0.25 Henrys and F is equal to 60 hertz. And this is where we get really frustrated that we don't use direct current all the time in the US, because this is why these things come about. It's because we use alternating current. This is why we have to worry about an imaginary part. In direct current, we don't have to worry about that. Calculations are much more simpler. Okay, so let's look at these things. So yeah, we've just got our equation. Z is equal to, so for impedance of an inductor, J omega L, omega is 2 pi times the frequency. So if I wanted to find Z, it's just J times, for omega L, it's 2 pi times the frequency times L. For this particular example, I can plug in the numbers, that it is J times 2 pi times 60 times 0.025. And so for Z, I get 2 pi times 60 times 0.025. 9.42 J. And it doesn't say on here, unfortunately. I think it's somewhere else in the question. But whenever we're talking about impedance, we're generally measured in ohms. And so that would be all we'd have to do to put this in rectangular form.